Hi, welcome back to my channel. So I wanted to share this setup that I have here. I'm quite pleased with the result. So as you can see, I have here a power supply which is powering this circuit, and so let me show you in some more detail what's going on. So here, as you can see, I have my HRF. So it's completely isolated from the rest of the system. I'm going to use this as a AM transmitter. Okay. Then I have my mixer that I already used in a few of my previous episodes. And the mixer is connected to the signal generator. The signal generator there is emitting a signal at, it's emitting the local oscillator for this mixer, so at 29 megahertz with the power of 7 dBm. Okay, this will allow us to down convert the signal from the HRF, which also will be at 29 megahertz, down to baseband, okay, at the audio level, basically, audio frequencies. Now, right, so the HRF is going to transmit using this antenna, and this transmission is going to be received by this other antenna that I have here, okay? So this is really a very crappy antenna, not at all good for 29 megahertz. I mean, not even the antenna of the HRF is any good at transmitting on 29 megahertz, but this is definitely even worse. But anyway, so this antenna is connected to the mixer here. So it's this cable here. Okay, so as the antenna is coming down and is connected here to the mixer. So the idea is that the mixer is receiving the RF input from the antenna and down converted it down to 29 megahertz. And the output of this down conversion is going to this breadboard. Okay, so let me actually zoom in here. It's going to this breadboard with this cable here, BNC adapter, which is going there. So let me see if I can focus a little bit. So this breadboard implements, there is a transistor there, which is barely visible, is this black piece there. And this is an amplifier, okay? There are two pots connected to this breadboard that allows me to regulate a couple of things of this amplifier. But anyway, the result is of this amplification is sent into two directions. One is this audio cable, and which is going to this speaker here. Okay, it's a very cheap Bluetooth speaker that also has this input for an audio cable. And the other the output is also sent to the oscilloscope. Okay, so this is the setup, and as you can see, it's pretty rudimentary. I mean, implementing the amplifier here on a breadboard, of course, there are a lot of losses, capacitance everywhere. So it's a very rudimentary setup, but let's see. Let me show you what's going on. So if I click start here, I'm going to emit a signal at 29 megahertz and 2 kilohertz. And as you can hear, probably, we are receiving the signal there on the oscilloscope, and the same signal is produced with the audio by the speaker. So of course, if I, so let me zoom out a bit so you have the whole view. If I change the frequency a little bit, so let me go, for example, to 29 and 3 kilohertz. Of course, the tone changes, and that is also reflected on the oscilloscope. Yeah, so here the counter, which is connected to the output of, to this channel of the oscilloscope, is measuring about, I don't know if you can see, but about 2 kilohertz and 60 hertz. Let me change a little bit here. So 29. I'm increasing the frequency by 1 kilohertz. And as you can see, yes, it's now it's 3 kilohertz and 55. Yeah, so it looks like there is, for some reason, a difference of 1 kilohertz between what is set here on the HRF and what we are actually measuring there after the down conversion. But anyway, So let me put it back. Actually, let me stop it. So as you can see, there is no more signal. I mean, the amplification is still going on, but it doesn't have much to amplify, so we get a very quiet signal. It's also quiet because this amplifier implements a low pass filter, so you know, every signal above 20 kilohertz is greatly attenuated. So yeah, lastly, let me show you. So I'm now going to use the AKRF as a Morse transmitter. It's pretty cool. So Morse code, it's still set at the same frequency. So I'm going to send a random message and see what happens. So I don't know if you can hear. For some reason, the signal emitted by the Morse application is much weaker than the one emitted before by the signal generator utility of the AKRF. We see basically nothing. So let me start it again. So let me zoom out slightly. I'm going to start again the message. So you see on the scope we basically see nothing. I'm not sure if you can hear, but I can still decode the message. So let me actually increase a little bit the timing because it's too fast. So I hope you can hear now. But so let me actually increase a little bit again with this pot. So I hope you can see it. But anyway, this application is transmitting at a much lower power for some reason, which is interesting. Perhaps I should let me see if changing the frequency helps. So 29 point not much really. So let me start again. No, nothing. So as you can see, I now increase the vertical resolution of the scope so we can see something. So the signal is quite weak. I can still hear it with my I mean, I can still hear the audio with my ears, but it's much weaker than the signal we had before. Anyway, it works. I'm pretty happy about this. It's my first, I think I can call this my first radio. And yeah, the next video I want to show you how I designed the amplifier, because of course you know, you can find the schematics in many books or websites, but to actually experiment, of course a breadboard is useful, but I found it very useful tool for simulating the behavior of circuits, which is called LT Spice. So I'm going to show you what I did in the next video. Anyway, that's all for this video. I'll see you next time. Bye bye.